Hello, ladies and gentlemen, this is Mrs. Gallagher, and today we're going to discuss the transformation dilation. A dilation is a transformation that produces an image that is the same shape as the original, but not the same size. So it's the same shape, but not the same size. A dilation is similar to the original figure. So a dilation is similar to the original figure. Dilations are centered around the origin, the 0, 0 coordinate, unless otherwise stated. So something that's important to understand about dilations is the scale factor. It is the image length over the pre-image length, which is going to be a ratio. Okay, so the scale factor is going to be a ratio. Two key concepts here. If the scale factor is greater than 1, then the figure becomes larger. So the figure becomes larger when it's greater than 1. If the scale factor is between 0 and 1, so it'll usually be a fraction, the figure becomes smaller. So if the scale factor is between 0 and 1, the figure becomes smaller. So the rule, when we go from xy, and this is f of x to f of y, where f represents the scale factor. So f represents the scale factor. So what exactly does that mean? That means we're multiplying each coordinate by the scale factor. So we're multiplying each coordinate by the scale factor. That's what that rule means. So let's do a couple examples of this rule before we graph a dilation. So in example 1, if a scale factor is 3, how would you write this rule? So originally you have an xy value. And if the scale factor is 3, you would write this rule by saying 3x and 3y. You're multiplying each coordinate by the number 3. So you're multiplying your x value by 3 and your y value by 3. Let's look at example 2. We have triangle ABC has vertices A, 0, 2, B, 4, 4, and C, negative 1, 4. What are the vertices of the image with a scale factor of 4? So our first step is to write our original coordinates down. So A is 0, 2. B is 4, 4. And C is negative 1, 4. And the question is saying, what are the vertices of its image with a scale factor of 4? So a scale factor of 4 means you're multiplying each coordinate, both x and y, by 4. So our A prime would be 4 times 0 is 0, and then 4 times 2 is 8. So our A prime coordinate is 0, 8. Next is B prime. 4 times 4 is 16. And once again, 4 times 4 is 16. So our B prime is 16, 16. And then our C prime, 4 times a negative 1 is negative 4. And 4 times 4 is 16. So C prime is negative 4, 16. So all you're doing with a scale factor is you're multiplying it by that number. So we multiplied by 4 to find the scale factor. So we multiply each coordinate by 4, both x and y, to find the scale factor. So in our next two examples, we're going to graph our dilations. So example 3, it says quadrilateral PQRS has vertices P, negative 2, 4, Q, 4, 4, R, 4, negative 2, and S, negative 4, negative 4. It is dilated by a scale factor of 1/2. What are the coordinates of the image? So our first step, we are going to write our original coordinates down. we have P, which is negative 2 and 4, Q, which is 4, 4, R, which is 4, negative 2, and S, which is negative 4, negative 4. So we want to now identify our new coordinates of this image. So we want to find our P prime, our Q prime, our R prime, and our S prime. Okay, so in the problem it says the scale factor is of 1/2. So what that means is we're multiplying each coordinate by 1/2. So our P prime, first one is negative 2. What's half of negative 2? Negative 1. Then we have 4. What's half of 4? 2. So our first coordinate, our P prime, is negative 1, 2. We want to multiply each coordinate by 1/2. So we are multiplying each coordinate by 1/2 in this problem, since the scale factor is 1/2. So now we have Q prime, 4, 4. So half of 4 is 2. Half of 4 is 2. So Q prime is 2, 2. Next is R prime. Half of 4 again is 2. And half of negative 2 is a negative 1. So R prime is 2, negative 1. And then lastly is S prime. Our original coordinate was negative 4, negative 4. So half of negative 4 is negative 2. Half of negative 4 is negative 2. So now we identified our new coordinates after we dilated with a scale factor of 1/2. So think of the dilation of your eye, your pupil. When you dilate it, you make it bigger or smaller. Same concept with doing this on a graph. All right, now we're going to graph them. So our first step is to graph our original coordinates, P, Q, R, S, the quadrilateral. So I'm going to graph those. So I graphed those 4 coordinates, and now I'm going to connect it to create a quadrilateral. So that is my original quadrilateral. And next I'm going to graph my dilated coordinates. So we're going to graph negative 1, 2. That's my P prime. 2, 2 is my Q prime. 2, negative 1 is R prime. And S prime is negative 2, negative 2. And now I'm going to connect that. And if you notice, when we multiply by a fraction, by a number between 0 and 1, the original image becomes smaller. So now let's look at part C. What do you notice about the angle measurements of the two figures? Well, let's look at these two figures. What do you notice here? They are similar. And we have similar figures. Our angle measurements are the same. So since our figures are similar, therefore the angle measurements are the same. Let's do another example together of a dilation. So example 4, triangle XYZ is graphed below. Draw and label triangle X prime, Y prime, and Z prime after a dilation using a scale factor of 2. So our first step is to identify our original coordinates, our X, Y, and Z. So X is negative 1, negative 1. Our Y is negative 1, 2. And then our Z is 1, 1. And now we want to find our dilation with a scale factor of 2. Remember, whenever we have a transformation, we're going to identify that using primes. So we want to find our X prime, our Y prime, and our Z prime. And to find our new dilated figure, we want to multiply each coordinate by 2. So our x prime would be, we have 2 times -1, which is -2. And then 2 times -1, again, is -2. Our y prime, 2 times -1 would give us a -2. And 2 times a +2 would give us a +4. And then our z prime, 2 times 1 is 2. And 2 times 1 is 2. So we're multiplying each coordinate by 2 since our scale factor is 2. So we multiplied each coordinate by 2. All right, next we want to draw our new dilated figure using our primes, our new coordinates. So our x prime is -2, -2. Our y prime is -2, 4. And our z prime is 2, 2. And we're going to connect it. And what do you notice here? This dilation became bigger, okay, because it was a scale factor of 2. It's greater than 1, so it becomes a bigger image. Now the next question, what do you notice about the angle measurements of the two figures? Well, these are similar figures, therefore they have the same angle measures. So they are similar figures, so they have the same angle measures. So dilations are similar figures with the same angle measurements. So now what I'd like you to do is the you try section. Please complete problems number 1 and 2, and we will discuss it in class. I suggest you write the original coordinates down first and then dilate them with the scale factors that are given for both problems. Thank you.